Welcome back. Now I'm gonna move to next question. And next question is R has two built-in functions related to binomial random variable. One is d binom and other is p binom. Look up these functions and use them to answer the questions below. So the question is, suppose you flip an unfair coin where p heads is 0.65%. 0.65, that is 65%. Round your answers to give two decimal places. What is the probability of getting exactly 7 heads in on 10 flips? So what it's saying is that experiment, there's an experiment where there's an experiment. There's an experiment where you have a coin flip for 10 times, and success probability for each flip is 0.65%. So that's what we have been given. Now what we want to do is we need to calculate the metric for probability of exactly getting 7 hits on 10 flips. And how do we do that? We have a function called p binom. I'm looking up the help for binomial distribution, and there's a function called p binom which takes input q, that is quantile, size, that is number of trials, probability of success in each trial, and whether tail is lower or upper, whether we are trying to see p is probability x is greater or smaller to x, or which is means lower tail, and uh, if higher tail means probability x is greater than small x, and x is a probability of success. X is a total probability. X is a quantile, and big X is what we have is the probability, to the sum of probabilities, or CDF. It is called CDF, cumulative distribution function. So what we are trying to calculate now is not cumulative distribution function, but PDF, probability distribution function, and that is called P binom. Okay, so P binom, let's do P binom here. Let's do p binom here and quantile. What we're trying to calculate? 7 out of 10 flips, right? So here, we need to calculate denom, that is probability of x, that is where x is given by it is d binom. It's not cumulative distribution function, but it is a denom. It's come the d binom. What is that? Is a probability distribution function. Denom d binom equal to PDF, and where here x is equal to 7, and size of the trials is 10 flips. 10 flips, right? Ten flips. So d binom is x7 x comma size. Okay, so let's run this. Hmm. Okay, so the probability distribution function is the probability of success is 0.65. That's the probability of success here. Now let's run this again. Okay, there is 25% probability. So it's going to be 25% probability. Okay, so that's the correct answer. Okay. So next question we have is, what is the probability of getting at most 7 head on 10 flips? 7 head on 10 flips. So that means head is up to 10 and not more than 10. So what it means is a lower tail, right? So probability of here small x is 7, and having head which is x here is less or equal to 7. That's what it means. For this one, we need to use the CDF function, and CDF function is this one. The CDF function is p binom. That's a CDF function. CDF function, cumulative distributive function, that's a p binom here. So we'll use p binom now, and we'll see that for p binom we need to put q, which is a quantile. Which is q, which is a quantile, and that's where x is. Q is x here. Q is x here, where x is now is 7. Quantile is 7, and quantile is 7, and size is 10. Size is 10, and probability of success is same as above. So probability of success is same as above. Only thing that changes is the q, and we'll put everything remains same here. Now we'll write the formula, or we'll write the function p binom Q, comma, size, comma, lower tail is equal to true. So lower tail is true. That means we are trying to calculate whether px is smaller or greater or equal to px, right? So it's going to be true here. So let's run this function. Missing probability is missing. It says probability is missing. Okay. P binomial size, comma, probability. We need to put another attribute called probability for this function, and let's run it again. Okay, it's 0.738%. That is 38. It's a 73%, which is correct. Now let's go to another one. The question is, what is the probability of getting at least 6 head on 10 flips? So that means we need to use the higher tail. That is, p is greater or equal to x. So that means p is greater or equal to 5, at least 5. So if it's greater or equal to 5, that means it is 6 head or more, right? So we need to use that function here, and let's use that function. For that function, we need to still use the p binom, but the values will be different. We are still doing the we are still doing the x, but x is greater or equal to 5. So here x will be greater or equal to 5. Then size will be still 10, but probability will be still same for this one, but lower tail will be higher. But let's do this one then. Q. Okay, Q is greater or equal to 5. That's what it is. Q. We are saying that Q will be greater or equal to 5. Okay. False. That's why we are looking for higher tail. Probably binomial where Q is 5, greater or equal to 5. That is here. And size is 10. Probably success is same. 0.65. Lower tail is false. That means we are looking for a higher value. So let's run this one again. Let's see what we get. 75%, which is correct. So let me quickly recap what we studied today. We studied about using R function called p binom and d binom. D binom is a PDF function, p binom is a CDF function, and we use those functions to calculate PD and CDF values for coin flips. Thank you so much.